Welcome to Easy Higher Mathematics.
Partially ordered set. For every partially ordered set, we need a partially ordered relation. That is, partially ordered relation. A relation defined on set A is reflexive, antisymmetric, and transitive. Then the relation is a partially ordered relation. So first we need a partially ordered relation. Then what is partially ordered set? Its short form is Poset. A set is called a partially ordered set or a Poset if a relation defined on that set is a partially ordered relation. That means this relation should satisfy these three conditions, that is reflexive, antisymmetric, and transitive. Let us go through an example. So this is one example. Let x equal to 1, 2, 3. We take the relation 1, 1, 2, 2, 3, 3, 1, 2. So what is the relation? Actually, relation is the cross product of this set. What is cross product? 1, 2, 3 cross 1, 2, 3. That means 1, 1, 1, 2, 1, 3. Then 2, 1, 2, 2, 2, 3. 3, 1, 3, 2, 3, 3. Total 3 elements. Total 9 elements. 3 into 3, 9 elements. So from that, we take a small subset, that is the relation taken as R is equal to 1, 1, 2, 2, 3, 3, 1, 2. So now we have to check whether X is a partially ordered set or not. So first one, what is the first one? First one is reflexive. That is, the first one is reflexive. Reflexive. That is reflexive. So what is the definition for reflexive? The reflexive is X related to X. That is, the elements should be same. If this is X, the second one should be X. That is, here 1, 1, 1. Our set contains 1, 2, 3. We should have 1, 1, 2, 2, 3, 3. So what is our set here? There is relation, that is 1, 1, 2, 2, 3, 3. These two coordinates should be equal. Hence, it satisfies the reflexive condition. So what is the reflexive? Once again, reflexive means these two coordinates should be equal, identical. Now, antisymmetric. So what is symmetric? If x comma y belongs to R, then y comma x belongs to R. That is symmetric. So antisymmetric means if x comma y belongs to R, then y comma x not belongs to R. So what is here x comma y? Here, let us take this R. That is 1 comma 1. You interchange the coordinates. 1 comma 1 interchange. That is 1, 1 only. Then 2, 2 the same. Then 3, 3 same. But the fourth one is what? 1 comma 2. If you interchange the coordinate means 2 comma 1. So 1 comma 2 belongs to this R, but 2 comma 1 not belongs to R. That means it is antisymmetric. One is transitive. What is transitive condition? If x comma y belongs to R, y comma z belongs to R, then x comma z belongs to the same R. What's the meaning? X comma y and y comma z belongs to R. That is, they identical. These two are identical. We take x and z. So now let us take this example. 1 comma 1, 1 comma 2 belongs to R. That is, here 1 and 1 are identical. We take 1 comma 2. But 1 comma 2 belongs to R, already exists in the given relation. Therefore, R is transitive. Then what? First we proved it is reflexive. Then it is antisymmetric. Now it is transitive. Therefore, R is a partially ordered relation. Since S satisfies a partially ordered relation R, the given set is a partially ordered set. One more example, that is, let A be any set. The relation R is defined by A is related to B if and only if A divides B. That is, first one divides the second one. We have to prove the given set A is a partially ordered set. Here we didn't have any element, that is A is the general set, and we take the relation as division. A related to B means first element divides the second one. So we have, if A is related to B implies A divides B. So when A divides B, if A divides B means B is a multiple of A, and the multiple should be an integer. So B can be written as K into A, where K is an integer. Now first one, reflexive. Reflexive means these two elements should be identical or equal, that is A comma A, that is A divides A. We know the elements, the same elements we can divide. So A 5 divides 5, 6 divides 6. So it is obvious one, therefore A is related to A. Hence R is reflexive. Now the next one is antisymmetric. What is antisymmetric? If A comma B belongs to R, then B comma A not belongs to R. That means if A divides B, then B should not divides, B does not divides A. That we have to show. So first you take A is related to B means A divides B. If A divides B, then B can be written as K into A, where K is an integer. That implies A is equal to 1 by K into B. But what is 1 by K? Since K is an integer, 1 by K is not an integer. Therefore, A is not multiple of B. That is, A is not multiple of, if A is multiple of B means this 1 by K should be an integer. Hence, 1 by K, since 1 by K is not an integer, B does not divides A. Therefore, B not related to A. So what we proved? Already we assumed that A is related to B. Now we conclude that B not related to A. Therefore, R is antisymmetric. Now the third one is transitive. You take two elements, that is A is related to B and B is related to C, then to show A is related to C. So A is related to B means what? A divides B and B divides C. We have to show A divides C. So A divides B means B is equal to K1 into A, some integer K1. And B divides C means C is equal to some integer into B. Now we can replace this B by this value, that is K1 into A. That is C is equal to, you keep this K2 and substitute the value for B, K1 into A. That is equal to K2 into K1 into A. Since K1 and K2 are integer, its product should be an integer. That is C is equal to K into some K into A. And K is an integer, that means C, that is C is an multiple of A, that implies A divides C. So we collected from A related to B and B related to C. Finally conclude that A related to C. Therefore R is transitive. Hence R is a partially ordered relation. Since R is a partially ordered relation, then the given set is a partially ordered set. That is, the A is partially ordered set. Thank you.